Have you ever heard of a brain being grown in a lab and then used for computing? The game you are watching on this screen is, in fact, being played by a brain grown in such a way. Today, I want to welcome you to the fascinating yet extremely dangerous world of organoid intelligence, which could prove far riskier than artificial intelligence. Artificial intelligence has grown at an enormous pace and has already taken over a wide range of fields, becoming an inseparable part of our lives. But alongside AI, another area has been steadily gaining attention in research: organoid intelligence. Our brain has an astonishing potential. Scientists say the maximum number of operations our brain can perform equals an exaflop, a 1 followed by 18 zeros. To put that into perspective, imagine 1 billion people, each doing 1 billion tasks, and all of them completing everything within a single second. That would be 1 exaflop. That is the scale of potential our brain holds. Naturally, this raises a question: if our brains can do so much, how powerful are today's supercomputers? At present, the world's most powerful supercomputer is Frontier, capable of 1.1 exaflops per second. It is built with 58 billion transistors, uses 20 megawatts of energy, stretches across 680 square meters, and has 145 kilometers of cabling, all at a cost of over $600 million. Yet, if you place an ordinary human being next to Frontier, their brain can perform at nearly the same level. This shows just how much potential lies within the human brain, though we hardly ever use it fully. If our brain has such capacity, why not use brain-like structures instead of silicon-based processors for computing? After all, the human brain weighs only about 1.3 to 1.4 kilograms and yet has immense storage and processing power. Some individuals, often called human computers, can even outperform machines in certain calculations when their brains are highly trained. On average, a human brain has a storage capacity of around 2,500 terabytes. Now imagine a brain grown in a lab, bigger than a normal human brain and engineered specifically for computing tasks. Such lab-grown brains could potentially outperform supercomputers while using far less space and energy. This is the foundation of organoid intelligence, which combines computer science and biology. This field took a major leap after 2013, when scientists discovered that even skin cells could be reprogrammed to grow into brain cells. From there, the idea emerged: if we can grow a brain in the lab, why not use it for computing? Over time, researchers have even trained brain cells to play simple games. For example, around 8 lakh brain cells were connected with electrodes and trained to play the game Pong. Within just 5 minutes, the cells learned how to respond to instructions and play. Studying the human brain is already complicated, whether in a living person or after death. In both cases, there are limitations to what we can learn. Similarly, lab-grown brains pose new challenges in data storage and processing. Still, with time, it's almost certain that enormous breakthroughs will occur in this field. There's another serious concern: ethics. Artificial intelligence is essentially software trained with data, but organoid intelligence involves a biological system. That means it could, in theory, develop thoughts, emotions, or even feel pain and pleasure. We cannot dismiss these possibilities. If organoid brains gain emotional responses, they might be able to manipulate humans emotionally, making them potentially more dangerous than artificial intelligence.
Subscribe for more videos. Thanks for watching.